Okay, hi guys. Um, welcome back to the video on remote access VPN. Um, in the previous video, which was the part 1, we configured remote access VPN, right? And that was for the finance team. And we tested and we saw that yes, the user was able to connect to the VPN, right? But for the design that we have, we said finance, this is their servers, right? So they come in through the VPN, right? They get an IP address and then they access the servers. But when we tested, we saw that yes, we are actually tunneling all the traffic to the network, but we could not ping the servers, right? That's where we actually stopped in the previous video. So if you've not watched that video, I encourage you to go back and watch it so that you have the full scope of what we have done. And because here what we are really going to be doing is doing some tweaking on the firewall in order for us to be able to achieve our goal, which is to allow finance users access their servers on the internal network, and then for them to also be able to go to the internet. Okay, because remember our the task was all traffic from finance teams, right? So long they are using the company's laptop, right? All their traffic, right? When they connect to the internet, all their traffic should come through the VPN tunnel to the London DC, which is like the HQ for this company. And then once it hits this ASA, it can go to anywhere it wants to go to, right? So in our own design, we're saying they should only have access to the finance servers, no access to marketing servers, right? So you can go through, remember there's already an IPsec side to side between these two locations, between the London and the FRAC DC. They are not allowed to go over that tunnel to access these servers. Neither are they allowed to access the infrastructure team server. However, they can go to the internet, talk to other providers, talk to third party, carry on their daily operational activities or whatever they want to do on the internet. Okay, so that's the scope of finance. And so what we did in the first part was to configure the remote access VPN, which was a bit, it took some time, but we finally got it up, right? So that is where we are starting from now. So I'm just going to use the next 2-3 minutes just to review the configuration we have on the ASA again, and then we can continue the testing. So this is my console to the ASA. We're on the active device, as you can see here. Okay, so what did we configure? Nothing much. What we just configured was that we created a tunnel group. So if I say show run tunnel group, okay, so this is our tunnel group for the finance department, right? The name is finance VPN. We gave it a pool, which we call the finance pool, and then we also enable the alias, which is something that pops up on the any connect VPN when you try to connect. Okay, so let me show you the pool. Show run pipe include pool. So this is the pool. So the IP, they have about 254 IPs to use. So we imagine finance is a very large department. They don't really need the whole IPs, but this is what we allocated. Okay, so when they connect, they pick an IP from this pool. Okay, so there's also a group policy that was tied to the tunnel group. What's the group policy? Which is this. So we can just say show run or group policy. Okay, so we created a group policy. Here we I think I did explain what the VPN filter does, right? So it's an access list for VPN basically, and then we also we are locking the tunnel, right? We said we want to lock this tunnel, we want to lock this group policy. What am I saying? So we want to tie this group policy to this tunnel, right? So yeah, so long as you're using this group policy, it will only allow you to connect to this tunnel group. Okay, we're going to see the application of this when we begin our testing. So for the split tunneling, this is also very important, right? We are not doing split tunneling, rather we are tunneling all the traffic to the gateway. This is our VPN gateway, which is the ASA. VPN simultaneous login, delete, no delay. We don't really have any business with this. What test is left? So if I say show run web VPN as well. So as you can see, we enable the web VPN outside. Those are the only thing we only added, and then we specified the AnyConnect image, and then we also enabled it. And then this command allows you to add the drop down. If you watch the previous video, you are going to see how we gradually figure these things out and got it working. Okay. Then we also have the user. So we've created a user, which is called finance, right? And then we tied it to the remote access. Okay. So I think those are the basic, those are the main components of this remote access VPN. And yeah, so we tested. So I'm going to just bring up the Windows computer, which is actually running on my VM, and then we connected, and then so this is the IP 192.168.1.30. That is the IP for, you see, that's the IP for the ASA. I've already explained how this switch is just in layer 2, so you can actually see the internet comes in through the green link, right, to these ASAs, and the IP is 1.30, right? So these two ASA are in active standby. So this is our primary currently. Okay, so here I'm just going to hit the connect. Okay, so yeah, so we just click, and then yeah, so we're able to see the drop down. Currently we just have one tunnel. Okay, and I already added this user here, so we just need to put the password. Okay, and then yeah, so we wait for the device to connect. Okay, yeah, so finance user is connected to the VPN. Okay, but we had some issues. Now we are tunneling all the traffic, so let's look at the routing table on the Windows computer. Okay, so we said route print. Okay, and then we also said IP config. Okay, so IP config tells us that yeah, this computer is assigned an IP, so this is the VPN, like the interface for the VPN, right? And then it has the IP 50.1, which is the first usable IP in the pool. Remember the pool that we specified. This is the subnet mask, and then this is the gateway. Okay, and then if you also go up and look at the routing table, which we used the route print to look at, so you see that for all traffic, okay, 0.0.0.0/0, the gateway is 192.168.50.2 on this interface. So this is the interface of this laptop, and you see it has a lower metric, right? So it's going to be preferred over the lower metric. Always have is always preferred, right? So it's going to be preferred over these other connections. Okay, and then we also went to the ASA. So if we go back to the ASA, no, this is not the ASA. So if we go back to the ASA, and then we also do show route for the pool 150, which is 50.0. So you see there's a V, which I think means VPN, right? So this is a host address. So this is 192.168.50.1/32. And it's saying to reach this network, I'm going to go over the VPN connection, right? It says connected via VPN, okay? So it's almost like it's locally connected, but it's over the VPN circuit, right? So that is it. But the challenge we have now is, yes, all the traffic comes to the ASA, but can we reach these servers? So let's check what the IP is for these servers. So this is finance 1, finance 2. So if you do, so as you can see, this is 10.00.20, which is this server. And this is 10.0.0.10, which is server 2. Okay. Yeah. So we can see from this server, we should be able to ping the gateway, which is 10.0.0.254, right? Same on this guy, ping to 10.0.0.254, right? Can they ping each other? So 10.0.0.20, can they ping .10? It should be able to. So 10.0.0.10. Yeah. So everything here is cool, right? And let's just test something else. Can they get to the internet? Yes. Cool, right? And check the second one. Can you go to the internet? Yeah. This is real internet though, right? So because I can also do to any IP you can take off on the internet that is pingable, because the internet actually comes from the EVNG, right? So there's internet actually coming here, and so it's amazing though, right? Okay. Yeah. So we've checked and everything looks good here, right? And so the question is, can this user now ping these IPs? Let's check that out. So let's go back. Now I have to go back to the Windows. So I'm going to say, okay, can you ping 10.0.0.10? Nope. Okay, so the VPN is up, but they can't reach any of the servers. Can we also ping 10.0.0.20? Nope. Okay. Then can you ping the internet? Nope. Okay, so the VPN is up, but there's still a lot of work to do. So we have to go to the ASA and ask the ASA why are you not allowing these connections? Okay, so let's go back to the ASA and see what's going on there. So an easy way to do that is to use your packet tracer tool, right? So I'm just going to say packet tracer, right? I'm going to say input. I'm going to say the inside interface, right? So we want to check, can this subnet, can this network go to that, get to this IP, which is the user, right? We could have also done it in the reverse end, but let's do it since we know the interface here. So I'm going to say inside ICMP, okay, and then we can say let's just pick the server, okay, which is 10.0.20, but it doesn't have to literally be an IP assigned to any device. I'm just going to do, so here it says I think the CMP type, it just says 0, SMP code 0, right, and the destination is 192.168.50.1. okay. So let's expand this. Let's see what the rules, the different rules is. Okay. Yeah, just tell us there's a problem, because you see the final result is drop. Okay. So you look at the different stages, right? So phase 1, access list. There's really no access list there, so it's allowed. Phase 2, is there a route lookup? There's a route lookup, and so you found the next stop, right, which is through the tunnel, right, and it says you should go to use the outside interface. Cool. It says looked at the NAT, right? I was once asked this question in an interview to explain the difference process, right, the ASA takes to actually process packets, right, and that's what this is just showing you, right? Then it says for phase 3, it says so what it's saying is if the traffic comes from the inside and it goes outside, what is it doing? It's nothing. It's to the, it said dynamic. Okay, so it says if it's coming from inside to outside, so this is your inside and the outside interface, right? So what that means is in this topology, anything that comes, right, hits the ASA and gets NATed to the public IP, which is 192.168.1.30, right? And that is just like a port address translation, right? So that is the problem we're having here now. So we don't want it to NAT, right? Do we want it to NAT? Of course not, because traffic that comes from this server and is going to this user, it doesn't need to be NATed to the public interface, right? We don't need to NAT. So that's what we need to fix. So how do we fix that? We need to configure what we call NAT exempt to say for whenever the traffic comes from this user, from this 192.168 dot I think I should just put the IP here just a bit. So it's going to be 192.168.50.0/24, right? Let's make it bold a bit and make it big. Okay, so now we know this is their subnet, right? So what we are saying is if the traffic is coming from 192.168.50.0/24 and the destination is this entire /16 or is /24, we don't want it to NAT, right? Because the problem is the traffic comes, goes into the ASA push it to the server, but when the return traffic comes, what happens? The ASA NATs it to the outside interface. ASA does route lookup, as you saw from there's a route lookup. Route lookup says send it to the outside interface. When it sends it to the outside interface, NAT kicks in. NAT look at its own rules and say, oh, anything coming from this IP, I have to NAT it to what? The public IP. Okay? And so what that means, it skips the tunnel actually. So the return traffic, instead of routing through the tunnel, what happens is being sent like naked, right, to the public internet, right? So we are not even so if you look at, there's no access list here. I say there's none, so there's actually translations going on for the IP, which is really not what we want. Okay, so we need to tell NAT to not NAT the return traffic, right? So if traffic comes, hit the ASA, don't NAT it, just forward it to 192.168.50. So that's what we need to do. Okay, so so let's do show run NAT. So we already have tons of NAT configuration already on the device. Okay, these were what we use for some of our overlapping subnets and for the site-to-site VPNs. Okay, so let me see if I can just, I don't want to cover the entire topology so that you can understand. Let's leave it here and drag it up a bit. Okay, all right, so how do we do the NAT exemption? Okay, so it's very easy. What we need to do is to say NAT, right? So let's check if we already have the objects. Okay, show run objects. So the 150, we already have the object for 150, and we already have the object for this subnet, okay, which is this London DC. Okay, so we just need to say NAT, which is exempt, right? And we say from, so we're going to say if it's coming from inside, right, to outside, right, because it's actually coming from the outside, right? So if it's coming from inside to outside, what do we need to do? We're going to say source static, right? And then we're going to say if it's coming from this subnet, right, we want to NAT but it to the subnet. So what that simply means is don't NAT it, okay? Because I'm NATing myself to myself. The IPs remain unchanged. We've talked about this a lot in the previous videos. So we're going to say if the destination to is it's also source. I think no, we just say static now. Static, okay, which is this. Also, it should not be NATed, right? And then we say no respond to proxy app, and then no, and then do route lookup. Okay, yeah. So that's really just the configuration. So let's look at it again. Yeah. So we are saying anything coming from this subnet, and the destination is the VPN tunnel. Remember, to get here, if you do the route lookup, what does it say? Send it through the tunnel, right? So so what that means is there's no access list. So access list type, here say type access list. There's no implicit rule denying it. Okay, so after the route lookup, which says send it to the outside interface, NAT looks at it. So at this point where NAT inspects the traffic, right? It's not really inspecting. I mean, look at the traffic, whether it should be NATed or not, right? So what we are saying here is don't NAT the IP, okay? Don't NAT, okay? So if it doesn't NAT, what we are saying is if it's coming here from here and the destination is this, okay, don't NAT it, okay? And then you know that the route lookup is saying send it through the tunnel, right? I mean, when we check, because when we say show, oh my bad, because when you say show IP, show route 192.168.50.0, it says send it through the tunnel, okay? So since we've configured the NAT exempt now, let's test again from the finance guys. Okay, ask the finance guys to test. So can I get to 20.0 now? Yeah, so we can get to 20.0. Can I get to 10.0, which is the second server? Yes. Okay, so what we just needed to add was the NAT exempt. Okay, now let's look at the packet tracer again. Let's see the difference now. All right, so this is the packet tracer. Now you see, okay, now you see that the NAT exempt is kicking in. Okay, it's a lot of stages. Okay, so here, just like before, there's a route lookup, okay, that says exit interface is the outside interface, right? Then NAT rules kicks in. What does NAT rule says? It says untranslated. Exactly what I was telling you. Okay, same for this guy is untranslated. Okay, because there's that NAT exempt. Okay, and then you have the different stages that come in per session. There's the inspects. Okay, so we have a policy that allows ICMP, as you can see from here. Okay, inspect defaults, which is ICMP. We've already gone through those stages. There's also additional NAT and so many other things that go. But in the end, what you see is it's an input interface is inside, outside output interface is outside. It said the action is dropped actually to the outside interface, but the difference is the traffic is not really is in reality using the outside interface, but it's going over the tunnel, right? So after the access list and the NAT applies, what happens? Then it gets encrypted and then it's forwarded over the tunnel, right? So the other stages that you have doesn't really apply, because you see the action still say drop, but the traffic goes out because of the encapsulation that has already occurred on the packet, right? It's already encrypted, and so the information, the upper layer information that you're seeing, or the headers you're seeing, is no longer doesn't apply to the actual traffic that is inside the tunnel. Okay. The next thing here is I think one of the tags has been achieved, okay, which says for these guys, they should have access to these servers, right? So they have access now. The next thing is they should be able to browse the internet. Okay, can they reach the internet? Let's check again. So let's say ping to 8.8.8. No, they can't go to the internet. Okay, so let's go back and ask the ASA, why can't they go to the internet, right? But let's look at it. So as you can see, the Windows does not currently have internet, right? I just want you to see this first. As you can see, there is really no internet here, right? There's no internet because we said all the traffic should be tunneled, right? All the traffic should be tunneled to the VPN gateway, which is in the corporate network in our data center. Okay, so the next thing is, let's ask the ASA again. Why are you not allowing them to go out to the internet? Okay, so we can just pull up that packet tracer that we used. So we're going to say if it's coming from, now we need to say here outside, right? We have to say outside here, I think, because the user is on the internet technically at this home, and it comes in through the outside interface, right? So if it's coming from the outside, okay, and the IP is 192.168.50.1, right? And then the destination is, say, 8.8.8. 8.8.8.8. What happens? Let's expand. Okay. So yeah. So it says access list. This is allow. It says there's a route lookup, right? Found next up as 1.1, okay, which is like the default gateway. So it's using the default route present. It says, so this stage is allow. This stage says allowed, right? This stage says allowed. This says allowed. This phase says drop. It says web VPN SVC, okay? I say there's a drop here for the VPN traffic, I think, right? Web VPN SVC. And then the final action, which is what you actually check here, also says what? Also say drop, okay? So basically what is happening is this, okay? The traffic comes, 192.168.15.0 is here, right? It's like, it's actually like it's residing behind the ASA, but it doesn't even match NAT because it doesn't match any of our NAT policy here, right? Remember, after the route lookup, we're supposed to see NATing, right? But there was really no NAT policy for it, okay? The ASA does not know how to handle traffic if it's going to the internet, okay? So we need to configure a NAT rule that says if it's coming from this subnet, right, then NAT it to the public interface, right? We have two options, okay? We can say if it's coming from this subnet, we want to NAT it to this pool, this subnet. We can just NAT it to the /16, right? And then because this /16 is already allowed, you remember there's already a NAT rule. Let's do show run NAT. Because it's show run NAT. So you see, we already have the after auto NAT, right? That says anything coming from, okay, we even did it for the /24, not the entire /16, okay? It can go out. So we can just take that /24 coming from the VPN and NAT it to this IP, and then we don't need to add any additional NAT here, okay? Or we can just create the object group for this NAT and also do it, also apply it to the public interface. So here's what this is what I'm saying. So I'm going to, let's try the easy one first, which is this, okay? And say, where's the object group? This is the object group, right? This /54, and then we can just add it here and then hit enter, okay? And then just show run NAT. So as you can see here, we've added it. Oh, this is wrong, okay? It's wrong because it's not actually coming from the inside interface. It's coming from outside to outside, right? So I'm going to remove this, okay? And then put it back. And then say, if it's coming from the outside interface and it's helping back to the outside interface, right? Show run NAT. So you can see that, okay? So let's test and then we come back and look at the packet tracer and see what it tells us. So I'm going to come here. I'm going to say ping to 8.8.8. Wow, this is nice, right? So this is nice. The internet should be back now, right? I don't know if I can try to browse the internet. This is actually a lab environment, so I don't know how. We can try to see if we can open Google. let's see, Google. It might not work because I don't think we're expecting HTTPX on. So if I do show run policy map, yeah, we are not expecting. So let's just add an inspection for HTTP. We can say inspect HTTP, inspect HTTPX, I think. I think maybe HTTP here stands for HTTPX. Let's see. Yeah, so they don't have HTTP. I think the HTTP most times stands for HTTPS, right? Because if I do show run HTTP, show run pipe include HTTP. You see for ASDM, we actually specify HTTP. So let's leave here. Show run pipe include HTTP. So you see I have HTTP enabled here, but this is actually running on 443, right? So let's just see if we can actually browse the internet. Let's see, it might not work because this is actually a lab environment. Okay, so another thing we can do, we can try to disconnect and connect back. Let's see, so that it's just reapply the policy. Okay, so let's try to reconnect, and let me enter the password. And hit OK. So it's going to get back the IP. Okay, so it's connected. Can we do a refresh? Okay, but it's not we are not able to browse. I'm not quite sure, but as you can see, we can actually ping the internet, so it's not really a routing problem. Probably it could be that inspection, but that's a story for another day. But I can also reach 4.2.2.2, right? Yeah, so if there's DNS here, I'm not sure if we have DNS. Okay, I could have been able to pin Google, but I don't think DNS is configured. Yeah, so it's really not part of the scope of what we are looking at. But if you come here and do show xlate, you should see that 192.168 is actually being translated, right? Let's see. Show, yeah, so you see, so outside, right? Okay, let's see, path address translation coming from this to this. Let me say show NAT. Okay, let's see if there's something that relates to, so everything here is just out. Okay, yeah, okay, yes. So let's look at this. This tells us there's a translated hit, right? You see, okay, for this subnet, okay, going to the outside interface. Okay, it says translated is 18, untranslated is what, 4. Okay, that tells you that yes, traffic is actually hitting this NAT row. Okay, yeah, so that's how it is. So what's the next thing we're supposed to do? So this finance should not be able to access the marketing and infrastructure team server. Okay, so the IP is 172.16.10.0/24. Okay, so the first thing definitely they will not be able to access it because we don't have any policy that even allow it in the first place. Okay, so because if I say ping to 172.16.10.252, which I think is the IP there, and if I go back to the marketing server, yeah, so that's the IP. Okay, so you see it's not reachable. But if I come to finance server here, you see this guy is able to ping it to 16.10.252. Yeah, I I was thinking to not, but it's able to ping it because we already have we've already sorted those things out, right? Show VPN session DB, learn to learn. Okay, so you see we have show crypto Exempt ASA, right? So we have this tunnel. I think it's iGV2 we are running here. Okay, between these two connection. Okay, all right. So by default, they shouldn't even have the reachability. Okay, so if I also show crypto IPsec SA, just to be sure, you see there's actually traffic between the two local and remote subnets, as you can see here, right? So definitely the finance remote user will not be able to access that thing. But the question is, what if we want them to access the server? What do you think we need to do on the ASA? Okay, if we want finance to be able to access this marketing server, what do you think we need to do? Okay, so maybe you can pause the video and think what we need to do, right? It's very easy. We need to manipulate the NAT rules, right? So we need to say if this IP gets to the ASA, we can simply just add this to the tunnel access list, right? So we add it here, we also add it here, and then it becomes part of the tracing traffic that gets encrypted, right? Because we definitely know the traffic comes here and then it goes out. Okay, but another simple implementation is just take this IP, NAT it to whatever IP you can carve out from here, because there's already a policy for this IP that allows it to talk to this subnet, right? So we can just take this IP, NAT it to this, and poof, it goes out. But it gets really complicated when you are tracing, and also when you are trying to map users to, because if I decide to take this IP and I map it to this IP, somehow it becomes really difficult to narrow down who the user actually is, right? Yeah, so you probably not want to go with that suggestion. What you really want to do is take this IP and add it to the tracing traffic, and it goes out. There's really no point demonstrating it here in this video, because when we do the marketing, when we set up the remote access VPN for marketing, we're actually going to do that. So we'll just use the marketing demo to show how the options we have for this user. Okay, so similarly, if they need to access the infra team server, we're also going to say that. Okay, so that's it for this video. Let me know what you think. Okay, and we'll move on to the next session, in which we'll build remote access VPN for marketing, so that in the end, what we end up having is two tunnel groups, right? Something else I want to quickly talk about is the VPN filter. Okay, no, never mind. We'll talk about it when we set up marketing. Okay, because for VPN, the question is, how does the VPN filter really apply? So you can apply VPN filter both to the user. We can apply VPN filter to the group policy, and there's something we call the dynamic access policy, right? And then you remember you also have access lists for physical interfaces. So we're going to review the hierarchy to know how we can actually apply these filters to VPN traffic. Okay, but that would be in the next video. Okay, thank you. So if you love this video and you want to see more real world examples of issues we face on a daily basis, or different solutions that we face on the real world, you might want to subscribe to this channel, so that when we make videos like this, you'll be among the persons that will get the notifications, right? And you'll be the first to see how the issues are solved. Okay, all right, thank you, and I'll see you in the next section. Bye.